In this question, a scientist is carrying out a reaction involving iron, Fe, and rhenium, Re, in an electrochemical cell as described by the following unbalanced equation. So we've got solid iron and rhenium 3 plus ions in solution in our reactants. And then we've got iron 2 plus ions in solution and solid rhenium in our products. Our goal is going to be writing a balanced overall equation. So to do that, first we're going to start by writing the balanced half equations for each of our reactions. We're starting with iron. So on our left, we have Fe solid. On our right, we have Fe2 plus Aq. So let's write that out. So the thing we're missing here is our electrons. So we need to decide, did iron gain or lose electrons to decide which side of the equation our electrons are going to be on. Now, since iron became iron 2 plus, that means it became more positive. In other words, it lost electrons. So if iron lost electrons, that means we're going to have some electrons in our products. And since we went from a charge of 0 to a charge of 2 plus, that means we must have lost 2 electrons. Another way to think of this is just to think of balancing the charges. Our total charge in our reactants to start with is 0. Our total charge in our products to start with is 2 plus. So in order to balance those charges on the reactants and the products, if we add 2 minus charges to our right-hand side of our equation, that's going to balance the Fe2 plus with the 2E minus. So we can go ahead and fill that in here. So we had iron solid in the reactants, and we had iron 2 plus ions aqueous and 2E minus in the products. The next question asked, was iron oxidized or reduced? Remember, oxidation is loss of electrons, reduction is gain of electrons. Iron has lost electrons here, so that means we have oxidation. Next to ask, is iron an oxidizing agent or a reducing agent? This is always going to be the opposite of what happened in the previous question. So if iron was oxidized, that means it's a reducing agent. The reason why is that in a redox reaction, we always have both oxidation and reduction occurring. So if iron is oxidized, that means that the other thing in our equation, here it's rhenium, must be reduced. So iron is helping to reduce the rhenium. So in that sense, it's a reducing agent towards the rhenium. Next, let's write a balanced half reaction for the half reaction involving rhenium. So we've got rhenium 3 plus aqueous in the reactants and rhenium solid in the products. So we've got rhenium 3 plus aqueous in the reactants, and we've got rhenium solid in the products. Again, we need to think about where we need to add our electrons. Now, we started with rhenium 3 plus, and we ended up with rhenium. So that means our rhenium 3 plus must gain 3 electrons to go back to being just rhenium with no charge. So we must gain 3 electrons in the reactants. That makes sense because our charges balance out. We've got 3 plus on our rhenium ion, and then we've got 3 sets of E minus to give us 3 minus. So that balances out to give 0, which is the charge we have in the products. So let's fill that out here. We've got rhenium 3 plus 3E minus gives rhenium. Awesome. So is rhenium oxidized or reduced? Here, rhenium is gaining electrons. That means we've got reduction happening. And is it an oxidizing agent or a reducing agent? Well, rhenium reacted with the iron and it caused the iron to be oxidized. So that means rhenium is an oxidizing agent. Okay, last step is to combine our balanced half equations to produce a balanced overall equation. So if we look at our original equation here, we've got an iron on the left and an iron on the right, and a rhenium on the left and a rhenium on the right. So it may look like it's already balanced. However, it's not balanced in terms of charge or electrons, because on the left of our equation, we've got a 3 plus on our rhenium, and on the right of our equation, we've got a 2 plus on our iron. So the charge is not balanced. So we're going to have to combine our two equations together so that the number of electrons and the charge is balanced. So in our iron equation, we've got 2 electrons on the right-hand side. In our rhenium equation, we've got 3 electrons on the left-hand side. We need the number of electrons to cancel out so that the number of electrons on the left and right are the same. Our smallest common multiplier of 2 and 3 is going to be 6. So we're going to need to have 6 electrons on the right and 6 on the left. So for our iron equation, we're going to need 3 sets of that because we currently have 2 electrons. So we need to multiply that by 3 to get to 6. And for the rhenium equation, we currently have 3 electrons. So we're going to have to multiply that by 2 so that we end up with 6 electrons in total. Then we're going to add those equations together. So we've got 3 Fe solid on the left. Also on the left, we've got 2 rhenium 3 plus aqueous. And we've got 6 E minus. So all I did there was multiply iron by 3, since we're having 3 sets of that equation, and multiply rhenium 3 plus and 3 E minus by 2, since that's our multiplier for that equation. Then in the products, we've got 3 sets of Fe2 plus aqueous, and we've got 3 sets of 2 electrons, so that's 6 electrons in total, and we've got 2 sets of rhenium solid. So now looking at our equation, we've got 6 electrons on the left and 6 electrons on the right, so those can cancel out. That leaves us with 3 Fe solid plus 2 Re 3 plus aqueous goes to 3 Fe 2 plus aqueous plus 2 Re solid. So we've now balanced our equation for the electrons. And if we check if it's balanced for charge, on the left we've got 2 rhenium 3 plus, so a total of 6 plus for our charge. On the right we've got 3 Fe2 plus, so that's a total of 6 plus for our charge. So the charge is now balanced. So we're ready to go ahead and fill in our numbers here. We had 3 solid iron, 2 rhenium 3 plus ions in solution, 3 iron 2 plus ions in solution, and 2 rhenium solid. And this makes sense because our atoms of each element are also balanced. We've got 3 ions on the left and 3 ions on the right, 2 rheniums on the left and 2 rheniums on the right. So it's balanced for our elements. It's also balanced for our electrons and our charge. Finally, we're asked how many electrons are transferred in 1 unit of this reaction. Well, looking over here, we had 6 electrons being transferred in 1 unit of our balanced reaction. So the answer here is going to be 6 electrons. So in this type of question, we've got a few steps. Firstly, we're writing balanced half equations for each element, adding electrons so that our charge is balanced. Next, we're deciding how many of each reaction do we need so that the number of electrons in the reactants will equal the number of electrons in the product so that they can cancel out. Then we're going to add those equations together, multiply by the number we decided we need, and we should find that the electrons will cancel out. And that gets us to our balanced equation.